Okay, now we're talking about the capacitor. The property of capacitor is capacitor can store the electrical charge. Capacitor has the ability to store the electrical charge. The amount of the electrical charge stored by capacitor can be calculated by equation Q equal to C into C multiplied V. V is a voltage connected to the capacitor. C is a capacitor. Voltage unit is volt, capacitor unit is farad. Q is a charge. Unit is a coulomb or C. So this is the equation. Q equal to C multiplied V. V is a voltage, C is a capacitor, Q is a charge. Voltage unit is volt, capacitor unit is farad, and charge unit is coulomb. So this is the equation to calculate the charge in the capacitor. Q multiply C, Q equal to C multiply V. And capacitor depending on the how capacitor construct. Here is a metallic plate. The plate or the cross area A, this called area A. Between here, we put a dielectric. The distance between two plates is a D. So this is the basic construction of the capacitor. Capacitor got a two plate. So plate got the area A. The distance between two plates is a D. So between two plates, we put a dielectric. Then we connect it to the supply. So the electrical charge coming into the capacitor and they are stored by the capacitor. So this is for the basic construction of the capacitor. So the capacitor value can be calculated. So the capacitor value is a depending on the distance, because of the distance is a determine the capacitor value. So the capacitor value C can be calculated. That will be E0 ER A by D. So in this case, E0 unit is a 8.854 into 10 power minus 12. ER is a relative permittivity depending on the material. A, the cross-sectional area of plate. So this is meter square. D, distance between two plates. So unit is a meter. So this is the equation to calculate the capacitor value. So capacitor got the two plate, they are separated by the dielectric materials. The distance is a D. So we write down the equation capacitor equal to E0 ERA divided by D. E0 is a constant, unit is a 8.854 multiplied 10 power minus 12. ER is a depending on the materials. A is a cross-sectional area of the plate, unit is a meter square. D is a distance between two plates, unit is a meter. So this is the equation to calculate the capacitor value. And then the charge stored by the capacitor can be calculated Q equal to C multiplied V. V is a voltage, C is the capacitor farad, Q is the charge, unit is a coulomb. So this is the way we calculate the capacitor value as well as the charge stored by the capacitor. Then we have to solve the one problem. Determine the charge of the 47 microfarad capacitor. So the capacitor value given the 47 microfarad. We have to calculate the charge. And that capacitor is connected to 12 volt supply. V equal to 12 volt. So the capacitor is 47 microfarad. We need to find out the coulomb and voltage at 12 volt. So we write down the equation Q equal to C multiply V. C is a 47 into 10 power minus 6 farad. Voltage 12 volt. So 47 multiplied by 12, you got it 564 into 10 power minus 6 coulomb, or 564 microcoulomb. So this is the charge value. This is the problem. And this problem, 800 microfarad capacitor store a charge of 0.005 coulomb. So in this case, capacitance value is given the 100 microfarad. The charge Q is given the 0.005 coulomb. We have to calculate the voltage. So let's see 100 microfarad Q 0.005 coulomb. We need to calculate the voltage. So we write down the equation Q equal to C multiply V. Then V equal to Q is divided by C. So this equation. So that we substitute Q value is 0.005. C is 100. Microfarad is 10 power minus 6. So that will be Q equal so V equal to, we calculate, so that 0.005, 10 power minus 6 go to numerator, so that will be 10 power 6 divided by 100. So that will be 0.005 is equal to 5 into 10 power minus 3, so 10 power 6 divided by 100. So that will be the 5 multiply 10 power 6 minus 3 divided by 100. So 5 multiply 10 power 3 divided by 100. So that will be 5 multiply 1000 divided by 100. So that by solving this one, the voltage will be the 50 volt. Voltage is 50 volt. The next problem, we have to calculate the capacitance. We have to calculate capacitance. In this case, this capacitor store a charge 250 microcoulomb. So Q is a 250 microcoulomb. The capacitor is storing a charge 250 microcoulomb when it is connected to the 200 volt supply. So in this case, Q is at 250 microcoulomb, voltage is at 200 volt. We have to calculate the capacitance value. So we write down the equation Q equal to C multiply V. Then C equal to Q by V. Charge divided by voltage, we can calculate the capacitance value. So that we substitute. In the place of the Q, we substitute 250 microcoulomb. Micro is at 10 power minus 6 and voltage 200. So that will be 1.25 into 10 power minus 6. So that will be 1.25 into 10 power minus 6 farad or 1.25 microfarad. So this is the answer. The next one. Capacitance store the charge 15 microcoulomb connected to the 10 volt supply. So that will be the next problem. The capacitor is connected to the electrical supply. Supplying for the V is at 10 volt. 10 volt, the capacitance value is a, we don't know the capacitance value. In this case, charge is a 15 microcoulomb. So that this capacitor connected to the 10 volt, the charge is a 15 microcoulomb, and then we want to join this capacitor to another supply. The voltage is at 32 volt. where to calculate the charge, how much charge. So charge depends on the supply voltage, but capacitor value doesn't change. Therefore, the first condition, supply voltage 10 volt, the charge is at 15 microcoulomb. We need to calculate the capacitance. So we write down the equation, Q equal to C multiplying V. Therefore, C equal to Q by V. So Q is a 15 microcoulomb, 15 to 10 power minus 3, voltage is 10 volt. So that will be 1.5 into 10 power minus 3 farad. So this is the capacitance value. The second condition, we have to calculate charge. Q equal to C multiplying V. In this case, capacitance value is 1.5 into 10 power minus 3, and the voltage is 32 volt. So we calculate the charge. So that will be the 48 into 10 power minus 3 coulomb or 48 millicoulomb. So this is the answer. The next one is a timing circuit. Timing circuit is we can connect the resistor and the capacitor connected together. Because the capacitor effect, the voltage will not rise to the instantly. It will follow the current. The this current is follow the this current. The difference from the resistor, if you connect the only resistor to supply, voltage is a straight line. Voltage and current are the straight line because of the we connect the time, the voltage and current build up are straight because of the resistor only. When you connect the resistor, only resistor, pure resistor to the supply voltage, when the time is going on, current will be increasing like this. But if you connect the resistor and capacitor in series, the curve will not be straight line. The time here is a current, so we go to this curve. So this is why that we can do this timer. So time constant tau is equal to the R multiplied C. R is a resistance, C is a capacitance value. So that it can take the some time to reach a certain point. This is we call the time constant. It's depending on the resistance and capacitance value. Tau equal to resistance and capacitance value. So this is the tau is a time constant. So that we can charge the capacitor. So to fully charge the capacitor, it will take the 5 time constant to fully charge the capacitor. It will take 5 time constant. So this is for the equation. So resistor and the capacitor different. When you connect the resistor to supply, this is the characteristic is a straight line. The more the time, the more the current. But if you connect the capacitor and resistor in series, curve will no longer be the straight line. It will go approximately to the curve. So because of this one, it's called the time constant. It can take some time to reach a certain point. So time constant can be calculated resistance multiply capacitance value. So that we can charge the capacitor. To fully charge the capacitor, it will take the 5 time constant. So this is the time constant equation. And therefore, based on this principle, we can do the problem. RC circuit. Resistance 120 kilo ohm, capacitance 36 microfarad. So this is the RC circuit. Resistor and capacitor are connected in series. This is the RC circuit. RC circuit, resistor and the capacitor are connected in series. So Resistance value is 120 kilo ohm. R equal to 120 kilo ohm. Capacitance value is 36 microfarad. C is 36 microfarad. We have to calculate the time constant. We have to calculate the time constant. So that we write down the equation. Time constant tau equal to resistance multiplied capacitance. Tau equal to RC. In this case, we substitute the value. Resistor is 120 kilo ohm. 120 into 10 power 3. Capacitor is 36 microfarad. 36 multiplied 10 power minus 6. So this is the we calculate. So there will be the 120 multiplied 36. So 120 multiplied 36. 4320. At 10 power minus 6 plus 3. So this is a 4320 multiplied 10 power minus 3. So this will be 4320 is multiplied 10 power minus 3. So the 4320 divided by 1000. So this is 4.32 seconds. The time constant is 4.32 seconds. We calculate. The next problem. Time taken for capacitor to fully charge. Time taken to fully charge the capacitor. We need to calculate the time taken for fully charged the capacitor. In this case, a 5 time constant. So 5 multiplied 4.32. So that will be 21 by 6 seconds. So that it will take the 21 by 6 seconds to fully charge the capacitor. So this is the way we calculate it. Another one is the time constant. Time constant is according to this way. 1 time constant, 2 time constant, 3 time constant, 4 time constant, 5 time constant. Cup time is a fully charged. So this is the time, here is the charge. So the 1 time constant, 2 time constant, 3 time constant, 4 time constant, 5 time constant. So this is the 5 time constant. Capacitor can be fully charged. So at the 1 time constant, how much only we charge? Only 0.63. Only 0.63 will be charged. If you supply the voltage, that voltage multiplied 0.63, only the capacitor store the 0.63 multiply supply voltage, that charge is stored. That's why it's stored. So this is the equation. So that problem, we connect the capacitor to the 24 volt supply. We have to calculate voltage across the capacitor at 1 time constant. So that we have to calculate voltage at 1 time constant. We need to calculate the voltage across the capacitor at 1 time constant. So to fully charge the capacitor, this means to get this 24 volt fully, it will take the 5 time constant. But only you charge the capacitor for short time, the capacitor voltage is not 24 volt, not full voltage, only the 1 time constant voltage. 1 time constant voltage only 63% is charged. Therefore, the voltage across the capacitor at the 1 time constant is 0.63 multiplied applied voltage. So this is the equation. Voltage across 1 time constant. Voltage across capacitor at 1 time constant. Voltage across the capacitor at the one-time constant is 0.63 multiply applied voltage. So therefore, this problem applied voltage is 24 volt, but the voltage across the capacitor at the one-time constant is 0.63 multiplied 24 only is a 15.17 volt. The capacitor voltage is only 15.17 volt. The capacitor got a different properties than the resistor. Resistor, if you charge the 20 volt, the voltage draw across the resistor also the 20 volt. But for the capacitor, it depending on the time. So the capacitor, we need a time to fully charge. Although you give the 24 volt to the capacitor will not retain the 24 volt because of the depending on the time constant. One time constant, it will only charge at 63%. It will take the 5 time constant to fully charge the capacitor. This is why the 24 volt is applied across the capacitor, but the capacitor will not retain the 24 volt. It will take the time. So the one time, it will charge only the 63%. Therefore, although you apply the 24 volt, after one time constant, the voltage across the capacitor is 24 multiplied by 63. You got the 15.17 volt. This is why that we use the capacitor in the timer circuit. Because of the time taken to charge and discharge the capacitor is the property that we utilize to construct the timer circuit. Okay, the next problem. Time taken to fully charge the capacitor 470 microfarad is 28.2 seconds. We have to find out the time constant. So there will be this is the capacitor value. Capacitor got the 470 microfarad. So fully charged. Time required is 28.2 seconds. Fully charged means the 5 time constant is 28.2 seconds. So we have to calculate time constant. So 28.2 divided by 5. So you got the 5.64 seconds. So to charge the 470 microfarad capacitor, it needed 28.2 seconds. So from here, you need to find out the time constant. So to fully charge, it will take the 5 time constant. 5 time constant is 28.2. Therefore, the time constant tau equal to 28.2 divided by 5. You got the 5.64 seconds. Then we also need to calculate the resistance because the time constant means capacitor and resistor are connected in series, so that it will happen that time constant. So that to enable to get the time constant 5.64 seconds, capacitor value we know it 470 microfarad. We need to calculate the resistance value. So we write down the equation tau equal to RC. Time constant is equal to resistance multiplied capacitance. So the resistance value is time constant divided by capacitance. So time constant 5.64 divided by capacitance 470 microfarad. Microfarad 10 power minus 6. So that will be 5.64 multiplied 10 power 6 divided by 470. So this is the way we calculate it. So the 5.64 divided by 470, 5.64 divided by 4708, you got that 0.012 into 10 power 6. So 0.012 minus 10 power 6, this is the 0.012 multiplied 10 power 3 into 10 power 3. So in this case, 0.012 multiplied 10 power 3, 12. 12 into 10 power 3 ohm or 12 kilo ohm. The capacitance value, the resistance value is 12 kilo ohm we got.